So today we will start about Java interfaces and packages, and then we'll discuss about access modifiers. So in the yesterday session, I have told about 5 types of inheritances and single inheritance, multi-level, hierarchy inheritance, multiple inheritance, and then hybrid inheritance. So especially multiple and hybrid inheritance, we cannot achieve by using class and extends keyword. So to achieve that, we have another concept called as a interfaces. Okay, so today we'll focus on interfaces. What is an interface? How to use this interface and how we can overcome, how we can achieve multiple and hybrid inheritance by using interfaces. And then we'll see packages and access modifiers. So first, let us talk about interfaces. So what is an interface? So I'll just write a few points about interface, like what is an interface and all, and then we'll discuss one by one. So interface in Java is a blueprint of class. You can just say interface in Java is a blueprint of class. Let me just write a few points about this and let's discuss one by one. So these are the important points which we need to understand. So an interface in Java is a blueprint of class. So what does that mean is, just like how we have created a class, and similar way we can also should create an interface. Syntactically there is no difference. So for example, here if I create a class, we use a class keyword, and here we use a class name, and inside the braces we will write variables and methods. This is called as a class. And the same interface also we will define the same thing, but only the keyword will be changed here. Instead of class, we use interface. Interface is a keyword and the name of the interface and open brace and close brace. And it is also contains the variables and also methods. Interface also contains the variables and methods. So in the syntactically, if you see very high level, it's similar, very almost seems very almost equal. So this is called as a blueprint. So first one is an interface in Java is a blueprint of class. The next point is interface contains a final and static variable. So from here you can see the difference between class and interface. So interface contains final and static variables by default. So very important points. Until unless we understood these steps, these points, we cannot work with an interface. So please focus on this. Interface contains final and static variables. So in the class, we can define the normal variables and methods. But in interface, variables or methods, variables must be static and final. Okay, by default, if I create a variable in interface, that variable is a static and the variable is also a final. So in earlier sessions, we have understood what is static and what is final. So if I create a variable with a static keyword, the variable can be directly accessed without creating an object. There's a common variable for across all the classes and all. There's a static. And the final means the variable value we cannot change. That is constant. Okay, if I say final keyword in front of the variable and that variable value is a constant, we cannot change that value. So these are the main behavior of static and final. So in interface, if I create a variable, that variable is by default static and final. Okay, we don't need to specify static final keywords. By default, the variable will be treated as a static and final. So that's the behavior of interface variable. Next point is interface contains abstract methods. This we need to understand. What is an abstract method? So an interface contains the methods just like a class, but these are all called abstract methods. What is an abstract method? So abstract method is a method which contains only the definition, not the body implementation. So for example, if I write a method, how I will write? It will say return type and a method name and bracket. Here we'll say parameters and open brace, close brace, and here we will write the body of the method. So this is a complete structure of a method. But what is an abstract method means? we will create only the definition of the return type, method name, and parameters. Okay, and then semicolon. That's it. We are not implementing this body. So this is called as an abstract method in Java. So if you give just only definition and semicolon, so we are not implementing anything here. This is just definition. So this is called an abstract method. This is called an abstract method. So why we need to define this? What is the use of this and all? I will tell you later. For now, just understand the terminology. Okay. So this is a abstract method. So abstract method means we have only the definition part. We don't have any implementation part. It's called as an abstract method. So in interface contains only abstract methods. We cannot implement the body inside the interface. So if you want to write a variable, that must be static and final. If I create a method, that must be abstract method. Only the definition we will write, body we don't implement. Okay, so that's the abstract method. So a method having only the definition but doesn't have any body called as an abstract method. So an abstract method is a method which contains the definition but not the body. Next point. So methods in interface are public by default. Suppose in a class, if I create a method, okay, so let's say if I create this method, by default, I haven't specified any access modifier for this, like private or protector or default. There are 4 access modifiers we have. So one is a public. We are going to discuss them in detail in a few minutes. Public, we have a private, and we have a protected. And if I don't specify all of them, that will be treated as a default. So default means it is not a keyword. So we don't need to specify any keyword like default. If I don't specify any of these, that will be treated as a default. That is also comes under one of the access modifier. So in class, if I create a method and if I don't specify any access modifier, it will be treated as a default because we haven't say anything here. But in interface, if I create a method, an abstract method, by default, it is a public. By default, the methods are public in interface. You don't need to specify any return type. Even if you specify any other type of access modifier type, it will not allow you. Okay, because interface methods are public by default. You cannot use any other access modifier in the interface. Okay, that's the one more difference. So methods and interface are public by default. Next one. Interface supports the functionality of multiple inheritance. So we discussed yesterday. So today we will see how it will support. And then we can define interface with interface keyword. So just now we have seen, if you want to define an interface, if you want to declare an interface, we use interface keyword instead of class. And the next one, a class extends a class, another class. An interface extends another interface, but a class implements an interface. This is very important point. So let me just give me the introduction about this. Suppose if I have a class, this is our class. Okay, I have another class. So if you want to acquire everything from this class to this class, so we use extends keyword here. This is extends. This is more important. Please focus on this. So class to class, if you want to acquire everything, we use extends keyword. Okay. And what's the point is saying? An interface extends another interface. So what does it mean is, if you have an interface which is defined, and if you want to extend this, or if you want to acquire everything from this interface, we need also one more interface. And interface to interface also, we use extends keyword here. Interface to interface also, we use extends keyword. But if we want to get everything, suppose I have an interface, this is our interface. In interface contains all our abstract methods, but there is no body for those methods. Only the abstract methods are available. But if you want to implement those abstract methods, we must have a class. Through class only we can implement those methods. So here we use implements keyword. So here we use implements keyword. So what we understood is class to class we use extends. That means this is a parent class, this is a child class. It is acquired everything from the parent class. Now interface to interface also we use extend. This is called parent interface, this is a child interface. Again, both are having only abstract methods. But interface alone cannot be useful. Okay, if I have only interface, we cannot achieve anything. So if you want to use an interface, class must be there, because interface contains the variables and abstract methods. There is no use of those variables and abstract methods until unless we implement them, right? If I create a simple body, there is no use of that method body, right? It should have certain purpose. So but interface contains the only methods. There is no other thing. So if we want to implement those interface methods, we must create a class. Okay, so interface to class. So if you want to implement these abstract methods which are already defined in interface, we must create the class. So here we use implements keyword. Interface to class we use implements, but class to interface is not possible. Class to interface is not possible. Okay, because this is a class which is responsible for implementing the methods. Interface doesn't have anything, it contains only abstract methods. So this is not possible. So these are the combinations it is possible. Class to class we should use extends keyword. Interface to interface also we use extends keyword. But again, what happens in this case, second case, interface which contains, let's say, m1 and m2, two abstract methods. And interface 2 is also contains one more abstract method called m3. Now what this interface will contains overall, it will also acquire everything from m2, m1 and m2 from the parent interface. Now interface 2 contains m1, m2 and m3. So all three methods again abstract. So if you want to implement this method, we must have one more class here. We must create one class. Here we use implements keyword, and then we have to implement all these methods m1, m2, m3 in this class. So that's the reason I told you, without class, interface is no use. There is no use for interface. We must have a class with an interface. So then only there is a use for. Okay. So this is the context of an interface. What is an interface? Interface in Java is blueprint of class. It contains final and static variables by default, and the interface contains abstract methods. An abstract method is a method contains a definition but not body. Methods in interface are public by default. Interface supports the functionality of multiple inheritance, and we can define interface with interface keyword. So this point I mentioned, a class extends another class, an interface extends another interface, but a class implements an interface. Okay, and the last point is we can create an object reference for interface, but we cannot instantiate interface. This is one more difference. Suppose if it is a class, we can create an object reference variable. Let's say a class name is some a. Let's say I'll create a obj is equal to new class. So like this I can write it. This is called as an instantiation part. This is a variable. So this is not possible in case of interface. So in interface, suppose if interface I is created, so I can create an interface variable like this, but we cannot instantiate interface. I cannot write like a new I. This is not valid. Okay, I can create an interface variable, but I cannot instantiate this interface. But how we need to instantiate this? We have to specify the class name here instead of interface name. Let's say class name is A here. So I should specify A here. But we cannot create an interface variable. Sorry, we can create an interface variable, but we cannot instantiate interface. If you want to instantiate, we must use a class name. So that's the last point. So an interface can create an object reference for interface, but we cannot instantiate interface. Okay, so what is, I'll tell you that, Oroshi. Okay, just wait for a moment. So now we discussed about what is an interface. Okay, what it contains, what is the behavior in interface. But now we will see what is the use of the interface. Okay, where we need to use the interface, why this comes into the picture. Now I'll tell you one use case. So when you are working on real time or developer or QA, if you want to work on something, we need a requirement. We should have certain requirement. So let us say there is a developer Okay, so a developer want to develop an application. So what's the responsibility of the developer? He has to develop an application. So if he want to develop an application, first of all, he required a requirement. He required a requirement. So based on the requirement, he develop an application. And not only requirement, you should also know about how to implement that requirement, how to develop that requirement. So overall, he needs two things. One is he has to know about the requirement and how to implement this requirement. So what is that? That means he should know about what and how. These are the two important things he should know. If you want to develop something, you should know about what should be developed and how should be developed. So these are the two important key things he should know about before developing an application. So what represents the requirement and how represents the design. Okay, what represents the requirement? What should I develop? And how represents the design? How to develop that requirement? The design says. Okay, so if he is having these two things, requirement and design, and then he can proceed and develop this application. But sometimes what happens is he know the requirement, but he doesn't know the design part or not yet completed this. He know what should be developed, but he don't know how should be developed. Okay, how to develop that requirement he doesn't know. But in this case, what he will do is he will just create some interfaces. But every requirement, if he want to develop, he will create a classes normally, right? So because the classes are having variables and methods, he will implement the logic within the class, the methods. But if we don't know the design, means if he doesn't know how to implement that, he will just create an interface. Let's say he will create some interface one and he will just create some variables and abstract methods. Abstract methods means we don't have the implementation, just only definition we have. So whatever requirements he know, he will just create methods and leave as it is. Okay, he don't sit ideal, he will just implement all the methods whatever requirements they have. But after some time, later point of time, once you get this design, okay, and this design means the design says how to implement these methods. So once he get the design, once we understood this design, then he will create multiple classes, class 1 and class 2 and class 3, and then he will implement these methods in multiple classes later. So once we know the design, then he will start implementing these abstract methods in other classes. This is actual use case. Okay, same thing is followed in Selenium case also. In Selenium also, Selenium WebDriver is also comes like this. Selenium WebDriver itself is an interface. So the group of people or group of developers, what they have thought is, they have thought like there is some kind of Java technology which will able to automate a web application. That's the main basic thought. What they have done is they know that requirement. Okay, we need an automation which will able to automate all kinds of browsers. Okay, so they don't, then that's the requirement, but they don't know how to implement this. So what they have done is they have created an interface initially that name it as a web driver. They have named that interface as a web driver. This becomes one of the component of Selenium. Okay, later we discuss. And in this interface, they have created whatever variables and abstract methods they have, but they don't know the implementation. They have created only abstract methods within this interface. So there are so many abstract methods they created, thousands of methods they have created. And then what they have done is they have make use of this interface for multiple classes. For each browser, they have created different class. Suppose if it is a Chrome browser, they have created Chrome driver class. Chrome driver is a class name, and this class is implemented these abstract methods. And if you want to work with the Chrome browser, we have to use these methods. Similarly, they created one more class called as a Firefox driver. This is another class, and this class is also implemented same methods, but internally logic can be different. Okay, and same method they have implemented by using Firefox driver class. And if you want to work with the Firefox browser, we have to use this class. Similarly, in market, n number of browsers are available. So for each browser they have created many number of classes, and same methods they have used, but the logic behind that is different. The implementation part is different for each and every browser. So this is the actual use case of an interface. So when you need to go for interface, if you know the requirement what to do, but how to, you don't know how to implement that requirement, in those cases you need to use in interfaces. Okay, so is it clear everyone? So that is all about an interface. This is a theoretical understanding of interface. So what is an interface, what the interface contains, why do we need to, why do we use interface, and in what condition we need to go for interface. Okay, so now let's see how we can implement this interface, how to use this interface in programmatically. And while working on interface, you need to remember these points, very important. Okay, now when I create an interface and when I use this interface in program, I'm going to touch all these points. Okay, so let's go. Here I'm going to create a new package for today, new class, and day 8. Oh, sorry, this is not a class. Okay, so now I'm going to create a few examples. The first one I'll show you. First one, like here we have, see, so class to class we use extends, interface to interface we use again extends, interface to class we use implements, right? So first we will see basic example how we can create an interface, how we can create a variables and abstract methods, and then we will see how to implement those abstract methods by using a class, using implements keyword. And once we understood this, then we go for multiple inheritance and other stuff. So let's see the basic example for an interface. Now here I will, so if you want to implement that interface, we must have a class. So without class, there is no use of interface. Okay, so new class, I'll just name it as a test. This is my class, and which contains a main method. Okay, so keep this class one side. Now here I will create an interface. I'll just say interface, and I'll name this. Here I will just create a few variables, and here you need to also give an interface name. So interface A is just a name of the interface. Now inside this interface, I will create a few variables. So as soon as I created an interface, as soon as I created an interface, a variable by default it is a static and a final variable. So if I define a variable like this, int a, okay, it will not allow you like that, because if it is a uh, final variable, we must assign some value. Final means constant, right? At least if you don't know the value, at least we should also assign at least a 0. Okay, so but we should not leave this variable like this, because by default the variable is a final. So here we must assign some value. Let's say I'll just say 10. So by default, as soon as you created a variable, it changed into italic. So here by default, the first part, by default, variables in interface are static and final. Okay, so now this variable is static and final. We don't need to specify any keyword here. So when I create a variable in interface, that will be considered as a static and final. So static means this variable is common for all classes. In future, if I create any objects and classes for this interface, this variable is a common, and then a static, a final. So this value we cannot change later. Now I will also create one method. So interface contains only abstract methods. So here I'll create M1. So this is only the definition. It doesn't have any implementation body. This is called as an abstract method. This is abstract method, and by default this is public. By default the methods are public, even though if you don't specify any access modifier. But in the class, if I don't specify any access modifier, that will be treated as a default. But here, if I don't specify, by default, it will be treated as a public. Okay, now I created an interface with a single variable and a single method. So with this interface, there is no use until unless we implement these methods using a class. There is no use of interface. But at the beginning level, if you know the requirement, you don't know the implementation part, then you can just define something and keep it like that. In future, you must implement this whenever you have a design. So now I will implement this interface. I need to implement this method. So where I can implement within the interface, we cannot implement this. We must have certain class. So here I will use this test class, and this test class will implement this interface. So here, what is the keyword I should use? Implements. Implements interface name. Okay. One more thing. So as soon as I say implements interface name, in this class, we must implement this abstract method. Okay. So otherwise it will not allow us, because see here, if I say as soon as implements A, it start giving an error. What is an error? The type test must implement the inherited abstract method from A.m. So what it is saying, if I say implements A, in this class, we must implement this method. Okay, we must write a body for this method. So now let us write. So main is also a method, right? Remember this. I'll keep one side. Now I will implement this method M1 inside the class. Now observe this, how to implement this. And if you want to implement this method, we should not change the definition. Use the same definition, but here remove the quotations, and now let's implement this. Okay, so here I will just access this variable. I will print this variable because that is a static variable, right? I can directly access from this. So I can say system.out.println. I'll just print the value of A. So what I have done is I have just created an interface with a single variable and abstract method. Now I have implemented this method within the class, that is test. But still, even if I have implemented, it's giving an error. If I put this cursor, it's saying cannot reduce the visibility of the inherited method from A. Once again, cannot reduce the visibility. Cannot reduce the visibility of the inherited method from A. What is that visibility? Visibility means access modifier. What it is saying is you cannot reduce the visibility of inherited method from A. So what is inherited method? M1 is an inherited method which is come from A. Here we have implemented. Here in the interface, by default methods are public. I said by default methods are public. Public is a higher, very higher access modifier. If I say public, that is available for everywhere, within the class, within the package, outside of the package, everywhere we can access those methods and variables. That's the public. But in the class, if I don't specify any access modifier, that will be treated as a default. And default is a little bit lower or lesser than public. Okay, but if I say a method as a public, that can be accessed within the class, within the package, in other packages also. But if method is a default, that can be accessed within the class and within the package. Outside of the package, we cannot access. So that means default is a little bit lower than public. So public is a whole, it can access everywhere. But default access modifier is a little bit lesser than public. And then protector is again lesser than default, and then private is completely restricted. Private is very lower level of access modifier. If I say variable method as a private, we cannot access this any other classes. So these are access modifiers. So in interface, by default methods are public, but in the class by default, if I don't specify any access modifier, that will be treated as a default. So what we have done here is we are trying to reduce this access modifier here. Here it is a public, but here it is a default. So that is not allowed here. Either we should specify same access modifier, or at least we should specify higher modifier, but we don't have any higher modifier more than public. Public is a higher one, so we must specify this method as public. Okay, so this is very important point, remember this. So in interface, abstract methods are public by default. So when I implement those methods within the class, we must specify the access modifier that is public. Okay, so are you guys clear this point? So why I have specified public in the class? Okay, so fine. So now I have implemented this abstract method within the interface. Now, if you want to call that method, how we can do that? How we can access this method? Through main method, right? So in the main method, if I want to access this method, in the main method, I must create an object for test, not for A. So we have to create an object for test class, and then I can access this method. So in the main method, create an object for test. T is equal to new test. Now I can access t dot m1. So now it gives a value. So one more important point I told you here. So I can create an object variable for the class. This is called instantiation part, and this is called as a variable. So in interface, we can create a variable like this, but we cannot instantiate. So the same thing I can write in different way. We can also write like this. You can use an interface name for a variable, but instantiation you can use a class like this. This is also correct way. So variable you can create for interface, but instantiation you can do this like new test. So this will actually create a memory, object memory, and this variable will point to that particular memory. So it can create a variable for interface, but you cannot instantiate the interface because interface doesn't have any memory by default. So even though if you create an interface, it doesn't have any memory location until unless you create a class, until unless you implement, even if you implement these methods where you are implementing within the class. So class itself is also doesn't have any memory until unless you created an object, right? These are all logical entities, means they doesn't have any memory until unless you create an object. So here you cannot create any object for this interface, but you can create an object for the class. So as soon as you created the object here, this will create a certain amount of memory. Okay, so you can create a variable for interface, but you cannot instantiate that. So that is one more difference. Okay, so if you still want to use this interface as a variable, but instantiation you have to do with the class name, not with the interface name. So you can also access same thing, a dot m1. So you can also access m1 method like this. See, now it also gives the same thing. So even a is an interface which contains m1 method. Even though it is implemented in class, so we can just call a dot m1, that will give you the same value. So both are same. Okay. So this is a basic example for interface and class. So interface should have variables or static and final, and methods are abstract. So interface alone cannot be used. No use of interface alone. But if you want to implement these methods in the class in future, then you can go and define the interfaces and keep it ready. And as soon as you know the design and how to implement those methods, then you can just create multiple classes and then implement that interfaces. Okay, so this is a concept of interface. Now let us see how we can implement, and one more thing. Okay, so let's see how we can achieve multiple inheritance. Okay, how we can implement multiple inheritance. And one more thing I told you here, right? So class to class we use extends, interface to interface again we use extends. Remember this point. Interface to interface means suppose you have a parent interface, I want to create one more child interface, you can still create, and you can do extends here. Extends, what this will do, It will acquire all abstract methods variable from parent interface to child interface. But again, if you want to implement this, you need a child class. So until unless you have this, you cannot, there is no use of these two interfaces. But here you use extends keyword, remember. And we have seen this interface to class, we use implements, right? So now let us see how we can achieve multiple inheritance. So let's again focus on what is multiple inheritance. What is multiple inheritance? Multiple inheritance means we have multiple parents for one child. That's the concept of multiple inheritance. So we have multiple parents for one child. This is called as a multiple inheritance. Now we will see how we can achieve this. Okay, so this can be achieved by using an interface. So if I create these three R classes, we cannot extend this into one class. So this is not possible. But these parents should be interfaces. These parents will create as an interfaces, not a classes. This is one interface and this is one other interface. This is another interface. So all parents are interfaces. Now to implement these interfaces, we must create a class. And this class can implement all these interfaces. Here again we use implements keyword. So this is a multiple inheritance. So one class can have multiple parents. Okay. So why is Uroshi is asking question? Okay, why is it not possible to extend them into a single class? So you're talking about interface. We can extend. So suppose we have an interface. This interface we must implement in the class. Okay, you're talking about this one, right? So can you just give me clarity here why it is not possible to extend them into single class? Extend them means you're talking about interface. Uh, three classes as parents. Okay, you're talking about this one. Okay. So here these three classes are parents, right? So here extends keyword doesn't support it. That's the main reason. Extends keyword, even though if we can create the three classes, okay, but we cannot implement. We can just implement only one class. We can extend only one class at a time, but we cannot extend multiple classes. If I want to extend them, we need to write syntax like this, right? So let's say class. Okay, let's say this class is A. Class A extends. Okay, okay, let's say assume that these are also classes. Okay, class A extends C1 comma C2 comma C3. So this is not possible by using extends keyword because extends keyword itself has a limitation. So extends keyword doesn't support to extends multiple classes, but single class you can do that. If I remove this, class A extends C1 and then you can extend that. Single class it is possible, but multiple classes it is not possible by using extends keyword. So that is the reason we have to create these parents or interfaces as in interfaces. And then we can use implements keyword here, implements, and you can write I1 comma I2 interface 2 comma interface 3 and so on. You can write any number of interfaces. Now this will achieve the multiple inheritance. So implements keyword can support multiple interfaces again, but extends keyword doesn't support multiple classes. So that's the reason again implements keyword is implemented. This is as per Java. We cannot do anything on this. Okay, as per the Java syntax, this is how they have designed. Okay, so a class can extend only single class at a time. It cannot extend multiple classes. That's the reason we create these are interfaces, not a classes, and then a class can implement these interfaces, multiple interfaces. Okay, now this can be achieved a multiple interface. So multiple multiple inheritance. Now let us see how we can implement this. So I will create one more class, multiple inheritance test. I'll name it as multiple inheritance test. Take a main method. Okay, so this is a class. Multiple inheritance test is a class. So keep this class on side. So first I will create parents. Okay, so first parent is interface. I'll name it as ABC. This is my parent interface. And here I will define a variable called X. I will just say 100. And I will also define a method called M1. So this is our one interface. So I will create one more parent interface. Interface, let's say XYZ. And within this, I will create a variable int, let's say y is equal to 200. And I will create a void m2 method. This is another interface. So why it is giving an error? I think it is already there. Syntax at the rate expected. Interface ABC. Int x is equal to 100. Void m1. Again interface. Sorry, I should remove the bracket. So interface xyz. Yeah. So interface xyz and a variable, and this is a method. So now I have two parent interfaces. This is one and this is one. So if you want to implement these methods, we must have a class. So now I will use this class, multiple inheritance test. This is itself is a class, right? So here I will use implements. Here I can write ABC, XYZ, and as many as interfaces. But if I use extends keyword here, we cannot extend multiple classes. That's the problem there. So here implements ABC and XYZ. You can just separate comma if you have more number of parents. Now, if I say implements ABC and XYZ, we must implement this M1 and M2 within this class. So let's implement this. So first void M1, I will implement M1, void M1. Now here I will just print the value of X. So here I'll just value of X, I will just say. So now it's giving an error here. So why it is giving an error? It's change method visibility to public, because this M1 method is a public by default in interface, but here it will treat it as a default. So we must add a public keyword when you're implementing that method. Similarly, I will also implement other method M2. So here system.out.println, I will just print the value of 1. Okay, so now this class is implemented these two interfaces. Now ABC and XYZ are parents of this particular class. So multiple inheritance test is a child class now. So if you want to call these methods M1 and M2, how to call? We create an object for this class. And let's create an object. Let's say T test is equal to new multiple inheritance test. And through this object, we can call M1 and M2. So test.m1 and test.m2. Okay. So now this is achieved multiple inheritance. We have two parents and one child. Let's run this. Run as Java application. Now it gives the exact value. So multiple inheritance is possible only with interface with implements keyword. Okay, we cannot use class and extends keyword for multiple inheritance. Okay, that's the reason interface came into picture. Okay, this is a multiple inheritance. So what is multiple inheritance? We have multiple parents and one child class. So we have multiple parents and one child class. That is called as a multiple inheritance. We have, let's say, these are parents and this is a child class. And we define these two are interfaces. Interfaces, and this is a class. Okay. Now let us talk about hybrid inheritance. So what is an hybrid inheritance? Hybrid inheritance is a combination of hierarchy plus multiple, both. So let's say this is hybrid inheritance. So these two are childs for this parent. This is parent. These two are the childs. And again, these two are the parents for this one. Okay. So for this, these two are the parents, and for these two, there is only one parent. So if I see the top portion, this is hierarchical inheritance. This is hierarchical inheritance. This is possible through class, because this class can extend this class and this class is also extend this. This is hierarchical inheritance. But here the bottom portion is a multiple inheritance again. So one contains the two parents. This is a multiple inheritance. So this also we can achieve by using hybrid, by using interface. Now I'll show you how we can achieve this. So let me just show you how we can implement hybrid inheritance. Just a second. Okay, so let's see how we can implement hybrid inheritance. So in hybrid inheritance, we need to follow certain things like this is one entity. Okay, so which that's a class or interface that we will decide later. Okay, and Preeti is asking question. Main purpose of inheritance is to reduce the code which is required again and again in different classes. Yes, you are right. But here I don't understand how we are able to do so. Okay. So as I said, basically the inheritance is basically used for reusability. Okay, suppose we have an class here, and this class contains a certain number of methods and variables. Now I created one more class. I can just I can extend this class, and here I can use all those methods. So this reduces the reusability like this. This is the main purpose of an inheritance. This is the main important thing. So in interface, what we are doing is, as I said, if I don't know the design part, if you know the only requirement, just keep all the stuff in interface. This is interface. And a later time, just implement that those methods in the class itself. Okay, and this class again we can extend in another class later. Okay, so this, let's say this is an interface, this is a class, and this is a class. Now here also there is a reusability. So an interface doesn't have any implementation part because we don't know the requirement. But later point of time, we have to implement these methods by using an interface. Okay, by using a class. So but this class, if you want to reuse, I can still reuse it. How this class we can again extend into some other class. And the reusability is always there. In everywhere the reusability is there. Okay, so here in this example, okay, so in, let's say here, this is a one interface and this is another interface. Here I created M1 method, here M2 method. Both are different. But when I implementing these two methods here, this is reusability. Suppose multiple inheritance test is actual class which is implemented these two. Okay, so here we have implemented this method. Suppose you have one more class, that class can extend from this class. That means the new method, the new class will get M1 and M2 both. So here you don't need to implement anything. So let us say this example. So we can also achieve the reusability every time, everywhere the reusability is there. So for example here I have interface 1 which contains M1 method. It doesn't have any code. I have interface 2 which contains M2 method. It is also doesn't have any code. Now I have implemented one class and this class can implement these two interfaces. So let's say I1 and I2 is implemented. Now this is the class which contains the implementation of the methods which are coming from I2 and I1 and I2 both. Now this class we can reuse again. So how to reuse this class? I can create one more class and this class can extend from this class. Okay, again these methods we are able to reuse in another class. Reuse in the sense we are not writing those methods again and again. We are just creating object and C1 and then we are able to access all the methods from this class, from this interfaces, all the parent classes or whatever and whatever parent interfaces we have. All the stuff we can still access by using this object. And again we don't need to create those methods. So if I extend this class into here, why I'm extending here? Because I don't want to recreate those methods. As soon as you do extends, these methods are again belongs to your child class. Okay, but if you don't do extend, what you should do, you have to implement, you need to write all those methods again freshly in the new class. So that is avoided here. That's the main intention of the inheritance concept. Okay, to avoid the duplication, and if I create something, we can reuse that. That's the main intention of interface. Okay, that's the main intention of inheritance concept. But if we here we talked about 5 interfaces, 5 inheritance types, and all 5 we can use wherever it is required. So based upon our requirement and occasion, we need to go for certain kind of inheritance concept. We don't prefer all in type of inheritance in all the places, and wherever whichever is required, so we need to apply that one. Okay, fine. So now let us see how we can implement hybrid inheritance. So what is hybrid inheritance? Hybrid inheritance means this will be like this. So this is one parent, this is the child, and this is the one. So this is called as hybrid inheritance. First, let us understand the architecture, and then we will decide what are all interfaces and what are all classes. We can define them later. First, let us understand the structure of hybrid inheritance. So this is the structure of hybrid inheritance. Okay. So in this hybrid inheritance, right, these two must be interfaces. Okay, this is one interface and this is one more interface. These two must be interfaces. Why? Because these two interfaces can be implemented using a class. So this should be a class. So class can implement multiple interfaces. So this part should be like this. So these are the two interfaces and this is the C, means a class. So this is a multiple inheritance here, this part. Now think about upper part here. Can we, let's say this is a class. Observe this carefully. Let's say this is a class. Can we extract everything from class to interface like this? Class to interface. Did I tell you this combination? Class to interface? No. We always talked about interface to class or else interface to interface. But this combination we have seen. We haven't seen this combination. Class to interface, right? This is not possible basically. So, but how we can achieve this hybrid inheritance? So, but if it is an interface, that is okay, fine. Because if it is an interface, what happens? If it is a class, what happens? Let's see both the combination. If this is an interface, this I1 can extend this, I2 can also extend this, and that will be duplicated again, right? So we don't go for interface. So there is only concept called as a class. If I define this as a class, we cannot extend this class or we cannot acquire everything from class to interface. That is not possible. So if I create this as an interface, there is an issue. If I create this as a class also, there is an issue. But how we can overcome this? So what is the ultimate goal here is C is a class which should get everything from I1, I2 and also class C, because C is also there in I1 and I2, right? Because these two interfaces should have the C. And finally, what is ultimate goal? She should have everything from I1, I2, and C is also there. C is also came into I1 and I2. I1 and I2 acquired everything from C. So C also should contain. So what ultimate goal is? This class should have everything from I1, I2 and also C. So here what I will do is, this class implements this I1 and I2, but this class extends this class. Here I will use extends. So here I'm going to show you combination of implements and extends both. Okay. So this I1 and I2 should be in interfaces and this should be in a class. And these interfaces we will implement in this class and this class will extend into this class. So, but overall, ultimately, we got everything from I1 and I2 and class, everything. That's the main whole idea of hybrid inheritance. So hybrid inheritance means at the end, whatever the child class we have should contains everything from I1, I2, C, everything. So I1 and I2 are the interfaces I will define, then I can implement them. But how I will get the C here now? If you want to get this C, I don't need to get this through I1 and I2. I can also directly get like this, right? By using extends keyword. Class to class, it is possible. Extends. So this is a class and this is also class. I will extend this class here. That is possible. So let's implement this. How we can do that? I will create one more class to demonstrate hybrid inheritance. Let's go in class. I will name it as hybrid inheritance. Hybrid inheritance. Let's take a main method. Okay, now I'll just keep this class one side. First I will define the parent. So let's go with the same structure. So first this should be a class, this one. So I'll create a class. So I'll just say class. Let's say A1 because A is already created. So A1, I will create a method called M1. So inside this method, I will just write a small message because this is a class. I can write the body of the class also, body of the method. So system dot out dot println. I can just write something here. This is M1 method from A1 class. A1 is a class. Remember this. Okay. So this is a class I created. So this is a this one, the parent class, first class. And then I will create these two interfaces, I1 and I2. So I will name it as a B1 and B2. So I'll name it as a B1 and then B2. So interface B1, and I will create one more interface B2. Okay, so in the B1 I will write an abstract method called M2 is an abstract method because it contains only abstract method, and B2 also contains one more abstract method void let's say this is let's say M2 is an abstract method and M3 is also an abstract method. So now I have this class which contains M1. Because of this is a class, I have implemented this method, and because B1 and B2 are interfaces, I have just created abstract method. I haven't implemented them. So now we are ready with this class with the two interfaces. Now we are not extending anything from this class to these interfaces, okay, because these interfaces doesn't need this class. Ultimate goal is we need to get everything into this child class. That's the main ultimate goal. So for now I'm not implementing this because this is not possible. Let me write once again. So I have created A1 is my class and B1 is one interface and B2 is another interface. Now here I will create one more class. So this is the structure actually, hybrid inheritance. So here these two are the interfaces I can implement by using this class. But this combination is not possible. Here and here it is not possible because B1 and B2 are interfaces, A1 is a class. So that's the reason it is not possible. So instead of that, what I will do is I will I will extend this class directly into the child class. Okay, this is also achieve hybrid inheritance. Now let's create this class. So this class I will use as is this one. Hybrid inheritance is also a child class, right? So now what I will do is this class will implement these two interfaces, B1 and B2. So I will just say here implements B1 comma B2. Okay, implements B1 comma B2. Now we have to implement this M2 and M3 within this class. So that's the reason it is giving error. And now along with this class should contain everything from A1, right? So we should also write here extends. You can also write like this, extends A1. This is also right. And but we need to write extends first and then implements. Okay, this is the right syntax. So what I have done is this class will implement B1 and B2 and A1. A1 is a class so that we have extends A1, and B1 B2 are interfaces so that I have implements B1 and B2. Now in this class we need to, so this class by default it will get M1 including the body, but M2 and M3 we have to implement here because they are comes from interfaces. Now let's implement here. So public void M2, so public void M2. So here I will write system dot out dot println. Okay, this is M2. This is M2 method from B1 interface. B1 interface. Now I will also implement other method, public void M3 system dot out dot println. This is M3 method from B2 interface. B2 interface. So now I have implemented both the methods in the child class. Okay. So now this child class is having everything from A1 is already get M1 and B1, B2 we have implemented methods here itself. So finally the C contains everything from B1, B2 and also A1. So if you want to call this M1, M2, M3 everything, we can just create an object for this hybrid inheritance in the main method. So hybrid inheritance mi equal to new hybrid inheritance, and then mi dot I can call M1 method, and mi dot I can call M2 method, and mi dot M3 I call all the methods. Now each method is come from different classes and interfaces. Now let's run this. Okay, so now all the methods have been executed. So M1 method come from A1 class, M2 method which is come from interface B2, B1, and M3 method which is come from B2 interface. So overall it is achieved hybrid inheritance. So hybrid inheritance is need to implement in this way. Okay, so guys, are you clear how we can implement all kinds of inheritance concept, single, multi-level, hierarchy, multiple and hybrid? Okay, so this is all about inheritance concept, inheritance and interface. So now we will see the next concept, Java packages and access modifier. So this is very simple concept. Java package. What is Java package? So normally, if you have any files in your system, you will create multiple folders, right? Why do we need package? Suppose you have some audio files, or you have some kind of video files, or some images or photographs. You will create multiple folders and you keep all those files in separate folders. So why do we need to do that? Because for maintenance. So suppose tomorrow if you want to get a personal file, you will go and search in personal folder. Or suppose if you want to get some movie file, you will go and search in movie folder. So that's only for maintenance purpose, right? Similarly, in Java, here we will create multiple packages. These are all called as a packages, Java packages. A package is a simple a kind of a folder which contains a similar kind of classes. Okay, suppose the classes which are belongs to some functionality will be there in one package, and the same the other classes which are belongs to some other functionality will be there in separate package. So based upon our requirement, we can just create multiple packages and keep all those similar classes into that particular package. And later if you want to get that particular class, if you want to use that class in some other class, we will refer that class by using a package name. Okay, so that's the main usage of package. So a package is a collection of classes or interfaces or some files, not only classes. In package we can create any type of file. We can create a text file, we can create an Excel file, we can create a class, we can create an interface. Any kind of file you can create inside the package. Okay, not only classes. So a package is a similar a kind of a folder, but in Eclipse we can see like a tree structure. But how this will store internally? So let me just show you. If you go and check this path, go to properties of your project, and then this is the actual path where your project is located. Now if you go and see this path, I'm just opening this path, and this is your project home directory. This is your project home directory. Now let's see. So under SRC, these are all packages are available. So if you go and open this SRC, you can see all the packages. See now, if for each and every package, you will see multiple folders here. Day 1, day 2, 3, 4. So as soon as you created a new package in your Eclipse, it will be created a new folder inside the home directory, project home directory. If I open the day 8, I created 3 files. So if you open the day 8, you can see 3 files. You can directly copy from here. Okay. This is a package. So package is a collection of files. You can simply say a package is collection of classes or interfaces or some other file. Any kind of files we can create under the packages. So all these files will be stored in the form of a folder structure in your project home directory. Okay. So how to access the files which are there in the package? So for example, I have a package. Let us see this. So I have a one package, let's say pack 1, which contains a class A. Okay. I have another package called as a package 2. I have a class called as a B. So now I want to use this class here in another package. Both are different packages, nowhere related, but both are there in the same project. Now I want to access this class in another package here. Okay, so how we can do it? I can just access this using this package 1. So here we need to use import keyword. Import. So we need to say package name dot class name at the beginning statement. And then we can access this class here. Suppose I want to extend this class here. So what I should do now, here I can just say extends A, and then I can complete this. This is how the class can be used in some other package. Okay. So, but if you want to use this class in some other package, we must import that particular package name dot class name. So if you want to refer a file which is present inside the package, we must refer that by using like this package name dot class name. Okay, this is how we need to import. Import is a command used to refer the particular class which is present in some package. Okay, so import is a keyword. Now, how to create the sub package? How to create the sub package? So one package can have multiple packages. Let us say I have pack 1. Inside this I have one more package called pack 2. Inside this I have to create a class. So this is my structure, how we can create. Let us see. So normally what people will do is, this is not correct, but people will try like this. So these are the tree, right? So suppose I have a pack 1 here. I will create a pack 1. This is my package. So if you want to create a sub package, inside this package, one more package, what people will do is just right click here, new, create package. They will give name like this, package 2 or else pack 2, and then finish. So now what happens is, it's not created under this package 1. It's created as a separate package. Now even if you go and see here in the folder structure, you will see two packages. They are not nested packages. So this is not right way to create sub packages. So if you want to create a sub package, suppose if you remove from here, it will automatically remove from here. Only thing is you need to refresh your project here. Okay, now pack 2 is gone. So if you want to create a sub package, you have to create like this. You should not take like this. Even though if you take like this, let's say new package. Okay, so here you cannot directly give the pack 2 like this. If I give pack 2 directly, that will be created as a separate package. So what should we give is, here we need to specify pack 1 dot pack 2. So first we need to refer to what is the parent package. Then inside is pack 2. Now click on the finish. Now here it seems it is created the new package. Pack 1 dot pack 2 itself is a new package, but it is not a new package. It's a part of pack 1. Now if you go and see here, only we have pack 1. Inside the pack 1, we have a pack 2. Okay, so this is how we need to create a sub package. So now pack2 is a sub packages of pack1. Suppose if I want to create a class in pack1, here I will create. Select pack1. I'll just create one class called as a test. Now this class is present under pack1. Now if you go and see in the pack1, the test.java is came here. Now if you want to create a class under pack2, so now you need to create this class, new class, and here I can just say test2. This is another class, test2. Now click on the finish. Now this class is created under pack2. Now if you go and see here, pack1, first pack1, inside the pack1 there is a test.java, it is available here. Then in the pack2, test.java is created. So in the pack2, test2.java is created. So this is how we need to create the packages. So in the real time, you don't see package names like a single word like this. You will see the like com dot, your project name dot, something like that, your company name dot. So it will be like that. Okay, so these are all packages and sub packages. And these are all user defined packages. We created our own packages. Sometimes Java will also give you some packages. They are called built-in packages. So there are two types of packages. We have seen how to create a sub package, and now there are two types of packages. One is user defined packages. So we have created our own packages. So these are all packages which we have created. So in Eclipse, these are all our own packages. And sometimes Java will provide you predefined classes. Okay, like java.util, okay, like that. So there are predefined packages which is already there in Java. So if you want to refer those classes, sometimes, okay, we are going to import those packages. So how to import? Again, we use import keyword to import those packages. So user defined package and built-in packages. So these are the two types of packages. User defined packages are created by us, and built-in packages means which are already available in Java. And if you want to use those classes, we need to go and use built-in packages. Okay, there are a few examples we have for these packages. We'll discuss them later, all about built-in packages, because we are going to see so many built-in packages. Even in WebDriver also, if you want to use certain classes, everything is a built-in package. Okay, so for now, just remember this: user-defined packages and built-in packages. So if you want to use or if you want to access specific classes from these packages, we have to import. We need to use the import keyword at the beginning of your program. Okay, so this is just a concept of packages. Very simple concept. Fine. So guys, are you clear about packages? What is package? How to create package? How to create sub package? How to import these packages in some other classes by using import command. Okay, so while practicing you will get to know one by one. So the last concept today is access modifiers. So there are four access modifiers we have. So one is, as I said before, public, and second one is a private, and third one is public, protected, and default, and then private. So these are the access modifiers we have: public, protected, default, and private. System.out.println is sub package. No, Justin. So that is not sub package. As I said before, system is a predefined class. Out is a static variable which is present in system class. Println is a method. So system.out.println is not a sub package. It's a class. System is a class, predefined class, not a package. Okay. Fine. So now let us discuss about this access modifiers: public, protected, default, and private. So let's see one by one. So first let us start with the lower level. Okay, private, default, protected, and then public. Okay, so if you want to understand this, first of all, let's understand the project structure, how we will create in Eclipse. So let us say, okay, I have a package. This is one package, and let's say this is another package, and all these packages are belongs to one project. I'm talking about only one Java project. Okay, so one Java project can have any number of packages. So now what package contains? Package contains multiple classes. Let us say this is the class 1 and this is your class 2 and this is your class 3. Again project 2, package 2 is also contains different classes. Let's say class 4, class 5 and class 6. So it is also contains multiple classes. So let me just name this. This is your pack 1 and this is your package 2. Okay. So now let us see one by one. So complete project which contains multiple packages and every package contains a multiple classes. Fine. So again, each and every class contains a variables and methods. Variables and methods. Every class. Now let us start implementing this. So for now, I'm just removing this pack 1 and pack 2. I'll remove these packages. Fine. So now first let us discuss about a private key. So let's start from very lower level. Okay. So private access modifier is accessible only within the class. So basically the access modifiers define the scope of variables and methods. So access modifiers basically define the scope of variables and methods where we can access them. So private is one of the access modifier which we can access only within the class, So what does it mean is if I create this variable or method as a private and I can access only within this class, only within the class. If it is a private, we can access only within the class. Those variables and methods we can access only within the class. Even outside of the class, we cannot access. Outside of the package, we cannot access. That access modifier is very limited to class. Okay, private is very minimal. So we can apply this private for variables and methods. So if I say variables or methods or private, this class, these variables and methods can be accessed only within the class. Outside of the class, we cannot access. Okay, let me just give you some example. So here I will create a new class. Let me just create one more package and name it as a access modifiers. So here I will just create one class. I will just name it as a simple big main method. So this is a class. Simple is a class. So let's see. I will create one more class above here. I will name it as a, let's say, class A. And here I will define a variable called int, let's say data is equal to something called some number, and I will make it as a private. Okay, and then I will also create one more method called void m1. Okay, so this is the method. I am not writing any body, just I'm demonstrating the private keyword. So private. So in this class A, I defined a variable called private, and a method is also a private. So if you want to access them, normally how to access, we will create an object for class A here and then we will able to access. Now I will create an object for class A. Let's say AOBJ is equal to new A. Now by using this AOBJ, I should able to access this data in M1, but it is not listing out here. So why? Because if I say, if I want to access this data, okay, let's say 08, okay. So now you can see here, I'm trying to access this data variable here. I want to change this value here. But what it is saying, the field a dot data, a field a dot data is not visible. A dot data is not visible. Why it is not visible? Because we make it as a private. And similarly, here a obj dot m1. If I call this m1 method, it is giving an error. So see this, the method m1 from the type A is not visible because we make it as a private. So what is the private keyword will do? Private keyword access modifier can accessible only within the class. That means outside of the class we cannot access. Only within the class it is able to access. Okay, that is completely restricted. So this will give you compile time error, and this will also give you compile time error. Okay, both are compile time error. Fine. So now let us discuss a next access modifier. So we don't use private most of the times. If you want to completely restrict it, then you can use a private. Okay. So private access modifier is accessible only within the class. Now let's go for default. Default is little bit higher than private. So when the default will applicable, if I don't specify any of these access modifiers, default will applicable. If I don't specify private or protect or public, default will applicable. Okay. So let's see default. So where we can access this default access modifier. So default access modifier, let me write it here notes. This is a private. This is your default. So if you don't use any modifier, it is treated as a default by default. Okay, and the default modifier is accessible only within the package. Default access modifier is accessible only within the package. Only within the package. What does that mean? If I create these variables as default, only within the package means across multiple classes we can access. So we can access in this class, we can access in this class, we can also access in this class. Everywhere in this package we can access. That is the default. So default we can access in this class, in this class, and in this class. All the classes which are present in the same package, we can access those variables and methods if it is a default. Now what I will do is I will just comment these two and then I will make them as a default. So I don't specify any access modifier so that it will be treated as a default. Now here we can access. There is nothing wrong in this because this A class is present in the same package and the simple is also present in the same package. So that's the reason here we don't have any issue. Here it is fine. Because m1 it doesn't have any method, so it is not printing at all. I'll write simple system.out.println, or I'll print a value of data. Okay, so now when I run this, you will get an output. So A is present under same package, access modifiers. Simple is also present under same package. So that's the reason we are able to access this in another class. Even if you create one more class here, this suppose if the main method is present in some other class, which is also part of the same package, then also you can able to access. Okay, nothing wrong in this. So what is the default access modifier is, we can access those variables and methods only within the package. Only within the package means within the classes, all the classes within the package. Okay, so this is little bit higher than private. So private is completely restricted with the class, only single class. The scope is only single class, and default scope is single package. Within the single package we can access everywhere. That is a default. Next one is a protected access modifier, and protected can be used only with inheritance. Okay, so protected modifier, let me just write this note. So the protected access modifier is accessible within the package and outside of the package also, but through inheritance it is possible. So there is a condition here. So protected is higher than default, no doubt in this, but higher than the default means we can access within the class, we can access within the package, we can also access outside of the package. Means I can also access those variables and methods outside of the package, but through inheritance it is possible. Without inheritance we cannot access again. Okay, through inheritance, that's the reason protected is completely belongs to inheritance concept. So if I say a variable as a protected, and those variables can be accessed. Those variables or methods can be accessed outside of the package also, but through inheritance it is possible. So I'll tell you how it is. Let me just show you. So here I will make these two again comment. Okay, now I'll make these two are protected. Now observe what happens. I will make it as a protected. Okay, now I have protected variable and protected method. Both here also I will just protect it. Observe this what happens. So Preeti is asking, within package no inheritance is required, right? That is up to you. You can also have inheritance within package. Okay, so within the package also you can, oh yeah, within the package you don't require inheritance. Okay, you can directly access because protected is higher than default. Sorry, protected is higher than default. Even if you say default, even if you say default itself, you can access within the package, right? So no question of protected. But when protector come into picture, if you want to access in some other package, then protector come into the picture. Otherwise, you will manage with the default itself. Okay, you don't go for protected then. So protected is came into the picture only if you want to access them in out of package. Okay, so the class A contains one protected variable and protected method. Now I will create one more package. This package is access modifiers, right? I will create one more package and I will name it as access modifiers 2. This is another package. Now in this package I will create an actual class. I'll just create a sample. This contains a main method. Now observe this. So simple.java and sample.java. Simple.java. So this class A is present under access modifier package, whereas sample is present under access modifier 2 package. So both are completely different packages. Now, if you want to access this method and variable outside of the package, that means in the sample class, directly not possible. If it is a protected, it is possible. But what we should do now, we need to extend this class here. I need to make A is a parent class of sample. So here we need to use extends A. Extends A. And then we can use it. So if I say extends A, what happens? The sample class will acquire everything from class A here. But one more thing is, this sample class doesn't know about A, from which package the A is coming from. It doesn't know, right? So what we should do now, we need to import that particular package. Import, what is the package name? Import access modifier. This is the package name. From this package dot A, specify the class name. So import access modifiers dot A. So but here A should be public class, okay? Otherwise we cannot access. So now access modifiers, what is saying? Access modifier dot A is not visible. Why it is not visible? Okay, so I think this class is present in multiple packages, so that's the reason I'm getting issue. So what I will do is I will separate this class. Okay, let's have this class as it is. What I will do is let's have one more package. Let's say pack 1. Okay, in the pack 1, I will create this one. Same thing. I'll copy again. Simple under pack 1. So now sample is present under. Let me just remove this. So sample is present under access modifiers 2. Now under pack 1, I will create one more class. Pack 1. So here I'll just remove this everything. Main. I'll just create ABC. It contains only protector stuff, nothing else. I make it as a public. So rename compilation unit to abc.java. Okay, so whatever class we have, that name also should be with the same. So here ABC. I'll rename it as a ABC. Okay, now it is fine. So now observe this. So ABC is present under pack1. Now here simple sample.java present under access modifier. So now observe this. ABC is present under pack1 and sample is present under access modifiers 2. Now I want to access this protected variable and methods here, means in another package and another class. So here how to use this, as I said, I need to extend this, extends ABC. So still sample class doesn't know about ABC, so we need to import that package. Let's say import where does ABC is present under pack1. So let's say pack1 dot ABC. Okay, now the sample know about ABC. Now what happens is sample is becomes a child class of ABC, right? So ABC is a parent class of sample. Now we can directly access those variables. So how to access these methods and variables? Because whatever is belongs to ABC, that is also belongs to sample, right? Also belongs to sample. So if you want to access them, we must create an object. Now sample dot s is equal to new sample, right? Now through this object we can access. Let's say this is the object. Yes dot I can access data. Now we can see here. I'll make it as 100. Now s dot I can call m1 method. Now when I run this class, it will give you output. So what does it meaning is, if I say a variable or a method as a protected, those variables and methods we can access in outside of the package also, but through inheritance it is possible. Through inheritance it is possible. If I don't use this extent, means inheritance, we cannot access. Okay, so this is the one of the access modifier. So private is very limited to the class, default is limited to the package, and protected is can be accessible outside of the package, but it is depends on inheritance concept. We must extend the class, otherwise we cannot. Okay, so the other one is a protected access modifier. We can access this package, we can also access in outside of the package, but here we must use extends keyword, otherwise we cannot access. And the last access modifier is a public. So public, we don't have any restrictions, we can access everything from everywhere. Okay, so what does it mean? If I say variable or method as a public, we can access within the class, within the package, outside of the package without inheritance. So that's the difference between protected and public. So public, if I want to specify variable or methods as a public, we can access within the class, within the package, and outside of the package also, everywhere. But when I use outside of the package, we don't require extends keyword now. We can directly access them. Okay, that's kind of flexibility we have in public. So for example, okay, let me just comment these two. I will make them as a public now. Let's copy. I remove this one and this one. Okay, so variable already there, right? So I'll just remove the public protected and I'll make it as a public. And this is also, I will make it as a public. Okay, so when I say public here we don't need to extend the class. Okay, so how we can do that? Let me comment this. I will write the same class again. Observe this. So here we don't need to extend ABC. So directly we can access. Only thing is we need to just import pack1.abc. Now directly we can access here. How to access here? We have to create class object for ABC, not for the sample. Okay, because sample and ABC nowhere related now because we haven't extended anywhere. So these methods and variables are present inside the ABC, so that we must create an object for ABC. So new ABC, directly we can create an object for ABC, and by using this variable we can access this data, s.data, s.m. So here we don't need to use any extends keyword. Without inheritance also we can access everywhere and everything if it is a public access modifier. Now when I run this, it will give you perfect. Okay, so this is your access modifiers: private, default, protected, and public. Let me just summarize it. If it is a private, we can access only within the class. If it is a default, we can access only within the package across multiple classes. And if we use protected, we can use within the package and outside of the package also, but through extends keyword it is possible. If I say public, we can directly access them in within the package and outside of the package, everywhere in your project. That's a public. Okay, so let me just share small presentation. Just I'll summarize all the access modifiers. If you see this particular table, you can easily remember this. Very simple. See, now I have listed all the stuff here. Private means we can within the class we can access. Yes. Within the package, no. Outside of the package by subclass, no. Outside of the package, no. So only within the class we can access. Rest of them not. If I say default, within the class, within the package I can access, but outside of the package we cannot. If I say protected, within the class, within the package also access, and with outside of the package also we can access, but through subclass it is possible. Subclass means extends, but directly it is not possible. And if I say public, within the class we can access, within the package we can access, outside the package by using extends keyword we can also access, without extend keyword also we can access. So everywhere everything is possible by using public access modifier. Okay, so these are all access modifiers concepts. So guys, are you clear? So as and when wherever we have a certain requirement, we need to go and use these access modifiers. And basically why access modifiers are required? To define the scope of the variables and methods. Okay, that's the main purpose of access modifiers. Fine. So that's all for today, and I will just stop it here. Tomorrow we'll see next concept, and I have assignment here, and which is again belongs to an interface. So write a program to demonstrate an interface. So just create one interface A which contains two variables and a method, and create one more class which will implement this interface, and just implement this method body in the class. And the second one, write a program for multiple inheritance by using an interface. This is again multiple inheritance. Create two interfaces, parent interfaces. First interface contains two variables and add method. Second interface contains two more variables and multiplication method, and implement these two interfaces by using another class. So this is a one more assignment which is for multiple inheritance. Okay, so try these two before coming to the next class. Okay, so bye for today. Let's see tomorrow.